So this video demonstrates the Laplace transform of a triangular waveform. Consider a triangular wave. It has a duration of 0 to 2 and its magnitude is 1 at t is equal to 1. This waveform, okay, we can the Laplace transform this from 0 to 1 it's go on increasing, from 1 to 2 it is decreasing. We know the Laplace transform of some of the predefined functions like unit step functions and ramp functions, exponential functions, sinusoidal functions. So in this case, we use a ramp function so that we will represent this waveform in terms of ramp function. And the slope for this is, it is a 1 by 1. Okay. Yeah. And the Laplace transform of unit ramp function, that is r of t, that is f of t is equal to t is 1 by s square. So we can make use this property. So the Laplace transform of ramp function is 1 by s square. And similarly, we are going to use one more property to find the Laplace transform of this waveform, that is a time shifting property. If the Laplace transform of f of t is equal to f of s, then for any real number of a t naught, f of t minus t naught into u of t minus t naught is equal to e to the power of minus t naught s into f of s. Means any shifting by a time period t naught, so its a Laplace transform is e to the power of minus t naught s into f of s. So to find the Laplace transform of this waveform, we are going to make use of these two. Okay, one is the ramp function, its Laplace transform, and the shifting property. So these are the two things we are going to use. So now, so it is continuously go on increasing. So this can be represented by a ramp function with the slope. Slope is y by x. Okay, that is 1 by 1. It is started at 0. It started at 0. It started at 0. So r of t started at 0. R of t into u of t. When I define like this, so it's gone increasing. But when I reach that 1, it should come down. Okay? It should come down. So that's why I'm introducing one slope. It is a ramp function at 1 with a slope of 1. That is 1 by 1. So it is a negative going ramp function. And I introduce at t is equal to 1. That is r of t minus 1, u of t minus 1. That's a minus 1. So when I added these two, so I'm getting this waveform. So when I reach at t is equal to 1, and I'm start introducing a ramp function with the same slope. So at this point, it's going to be constant. Okay, so it go on constant. But at 1, t is equal to 1, it has to come down. Okay, so it has to come down. So next, so again I have this one. So at the 1 it has to come down. So I'm introducing one more ramp function with the same slope, that is minus 1 by 1 r of t minus 1 u of t minus. So for this, if I introduce, it start coming down. It's coming down and it go on increasing. It's gone increasing. So what is the slope? Slope here is 1 by 1, means that between this 1 to 2, means at this 2, the slope will be crosses. Okay, it go on increasing. But so at when I reached the 2, it should stop. It should stop. So that I am going to explain in this slide. Okay, so when I reached at these 2, so one ramp function, that is at introduce at 2 with a slope of 1. So it is introduced at time period 2, r of t minus 2, u of t minus 2. So when I added these two, so finally, so we are getting this waveform. So total uh, one is a ramp function started at 0, that is r of t u of t. Second one f2 of t minus 1 by 1 r of t minus 1 u of t minus 1. Again third one more I have introduced, minus 1 by 1 r of t minus 1 u of t minus 1. So 2 brings down. And fourth one is, so when I cross these two, it's gone increasing. To stop this, I introduce a positive going ramp function. So that is a fourth one. So total 1, 2, 3, 4. That is r of t, u of t, minus 1 and minus 1, minus 2, r of t minus 1, u of t minus 1, and r of t minus 2, u of t. So this is the f of t. The Laplace transform of this one is, for ramp function, that is a t 1 by s square, and it is delayed by a unit time minus 1. So its magnitude is 2, that is minus 2, 1 by s square e to the power of minus s. Then plus, it is again a ramp function. Its Laplace transform is 1 by s square. It is a shifted by a time period minus 2. So we are going to make use a time shifting property e to the power of minus 2s. 1 by s square is common. So 1 by s square, 1 minus 2 into e to the power of minus s plus 2 into plus 1 into e to the power of minus 2s. So the Laplace transform of that waveform is 1 by s square, 1 minus 2 into e to the power of minus s plus 1 into e to the power of minus 2s.